Hello, today we're continuing our discussion on chemical equations and reactions and learning how to balance coefficients in reaction equations. In fact, this procedure is quite challenging and there are a multitude of techniques to achieve a balance in chemical equations. The technique I introduced you to in the prior lesson is referred to as the least common multiple. This technique is handy for equating all sorts of chemical interactions. In the previous lesson, we reviewed connections and decompositions. Let's explore the purpose of this reaction and how this method can equalize various chemical reactions. Let's assume there is an interaction of the following nature. Aluminum undergoes a reaction with ferrum 3O4, which is commonly referred to as iron scale, and this is what we call it. And at the temperature, since this reaction requires exactly this condition, during the reaction, the replacement of aluminum oxide, aluminum 2O3, occurs and iron is released. There will be a substitution in this reaction. Let's see how we are going to work in this case and where we will start from. Okay, initially we need to locate the element with the greatest index. Oxygen possesses the highest atomic number. Let's take a look. Here's 4 of them, here's 3. Iron, though, is also 3, but in this case, the index 4 for oxygen is the highest. So we have 4 oxygen atoms on the left side and 3 on the right. Next, we need to find the least common multiple of 4 and 3 for this element, which is oxygen. Between the numbers 4 and 3, the smallest multiple will obviously be 12. We will sign this at the bottom, in this case 12. We signed at the bottom because we have temperature conditions for this reaction on top. So we will write this number at the bottom. So at this point in time, moving forward, what do we do with the number that is a multiple of 12? Subsequently, the next step in the process is to begin dividing 12 for oxygen. We divide it by the index on the left by 4 and obtain the result of 3. This number 3 is set here as a coefficient. Next, on the right side, we divide 12 by 3. And we get a coefficient of 4, which we put to the right of aluminum 2O3. They put oxygen, leveled the playing field. Oxygen ended up being the first in our equation. Now let's proceed to the next item. Following that, we can consider something like iron, for instance. So let's prioritize iron and make it the second in line in our list. Okay, let's thoroughly analyze this. What is the amount of iron that we have on the left side? On our left side, we have 9 of them, and on our right side, we have 1. So it turns out that for the element U, we have iron. I'll write it here. On the left side, we have 9. On the right side, we have 1. All right, we ended up with a coefficient of 3 on the left side for oxygen and a coefficient of 4 on the right side. Now, moving forward, we have to do the next item. The next item on the list is iron. He is rated as a 9 on the left side, whereas on the right side, his rating drops to a 1. So the multiple for iron is determined to be 9. Consequently, the answer is 9. In order to obtain the coefficient, we divide 9 by 3, resulting in a coefficient of 3. Here it is, number 3, and it's standing right there. And on the right side, we divide 9 by 1. Therefore, our final result is that we end up with a total of 9 on the right side of the iron formula. Now we simply need to equate the final element. This element is aluminum. Let's display it now in red right at this location. And once again, we're pondering how much aluminum we have left. On the left side, there's 1 aluminum, and on the right side, there's 8. So on the left side is 1, and on the right side is 8. Then the multiple for oxygen will be 8. That was for the iron, and this was for the oxygen. Following that, we commence dividing 8 by 1 to obtain the result. So it is going to be 8. The probability or likelihood of it happening is 8. Moving to the right, we can see the calculation of 8 divided by 2, which results in the value of 4. And we have a coefficient of 4 right there on the right side, so we simply need to check. Let's examine this as an oral assignment. Okay, we have 8 aluminum on the left side and 8 on the right side, 9 iron on the left side and 9 on the right side, and 12 oxygen on the left side and 12 on the right side. Okay, our equation has been equated. That was a reaction, as you can see. However, let's demonstrate another instance of a substitution reaction, which will also occur, and the equation will be balanced in precisely the same manner. Okay, we can make use of zinc and hydrochloric acid to initiate the reaction, don't you think? Therefore, we obtain chloric zinc, zinc chloride 2, and hydrogen gas is liberated as a byproduct of the reaction. So, here we go again, figuring out where to start from. In this case, we can start with either chlorine or hydrogen because their indices are the same. Well, let's say we start with chlorine. On the left side, we have 1 chlorine, and on the right side, we have 2 of it. So it turns out that the common multiple between the numbers 1 and 2 is 2. Let us write it down in this location above the arrow. Now we begin the process of dividing 2 by 1 to obtain the quotient. So it turns out that we will have a coefficient of 2. We put it right here in front of the HCl. Now we divide 2 into the common multiple, and we obtain a quotient of 1 through the division process. The unit is placed before Cl2. We don't write down the unit. All right, we've equated the chlorine. Let's switch to hydrogen, buddy. Hydrogen will be our second in terms of equalization. What is the amount of hydrogen on the left? On the left side, we obtain a total of 2 hydrogen atoms. How much hydrogen on the right? There's 2 hydrogen on the right. And so it turns out that hydrogen is equal. However, the common multiple for hydrogen would also be 2. We should write it down in this location. However, hydrogen is equivalent. Presently, we simply need to verify the zinc. We will consider zinc as an element. Let's underline it here with a wavy line on the left side. We have 1 zinc on the right side as well. So here we have 1 and here we have 1. The coefficient for zinc will be 1. Since the zinc is the same on both sides, we can conclude that zinc is in balance. Therefore, our equation is balanced. However, we can definitely check it. So on the left side, we have 1 zinc, and on the right side, we also have 1 zinc. Thus, the number of zinc atoms is equal on both sides of the equation. Moving on to the next element, hydrogen. On the left side, we have a total of 2 atoms. On the right side, we also have a pair of hydrogen atoms. And the chlorine remained in order to conduct testing. We have 2 multiplied by 1, 2 of chlorine on the left side, and on the right side, we also have 2 chlorine respectively. All our equation is equated. Let's read this equation. Zinc plus 2 H chloride equals zinc chloride 2 and plus H2. So 2 examples that we demonstrated, they are equalized by the identical method. It transpires to be the method of least common multiple. And this technique works in both of these examples of substitution reactions. This approach works for other types of reactions as well, which we can balance and more complex interactions. And this method is pretty good at helping, in this case, with coefficient selection. Well, that's all for today. Goodbye.